In this video, we are going to go over our antenna array analysis tool. So all you have to do is to type in antennaarrays.com, and here you are. So while you are checking out the layout, let me have a few words about the audience of this tool. So if you are an undergrad student or a hobbyist and you like to learn about the antenna arrays with playing around with the numbers and checking out the curves, this tool is a great place for you. If you are an experienced antenna engineer, you want some quick but accurate calculations of antenna arrays, or you want some comparison curves, some visualizations, again, this tool is going to be a great help for you. So let's go over how we can use this tool. So we have both linear and planar arrays, and let's start with the linear case. So for our linear case, let's say we have 17 elements and they are half wavelengths apart, and here we have the radiation pattern of those elements. So we can show the grid here. Here are the elements, 17 elements, half wavelengths apart. Here we have a switch to show the annotations as well. So by annotations, we mean the peak value, the half power beamwidth here, and the side lobe. And those values are also populated here in this table. We can also switch to polar format if you prefer that one. So moving to the next things, we can scan our beam, let's say to 5 degrees, and here the pattern moved to 5 degrees. If we want to move it to 15 degrees, we can see it move to 15 degrees. Here we can also show you the excitations. By excitation, we mean the amplitude, let me hide the grid, the amplitude and the phase of the array elements. So here the amplitude is uniform. We applied a progressive phase to scan the array to our desired angle. Okay, so that was the scanning. Next thing is to show you the amplitude tabling. For that, let me switch back to Cartesian form, hide annotations. So before going over the amplitude tabling, let me show you here on the right side, we have the lesion area. If we want to compare a couple of curves, we have the option to keep the current curve here. And then now we come here, apply some amplitude tapering. So for example, we want to apply 25 dB or 30 dB of side lobe. And here we have the second curve, and we can keep that one as well. Let's make the current one invisible, so we have the comparison of the two. We can clearly see the difference between side lobes, and here we can see that our amplitude tapering, we have to apply 11 dB of tapering to the element at the edge to get to 30 dB. And here we have the element pattern. By default is cosine. You can apply, enable it, and then you should choose the element gain you want. By default, we had to leave it at 5 dB. Okay, let's move to planar array. So for planar array, let's start with the grids. We have 3 types of grid: rectangular grid, triangular grid, when the elements are, the rows are staggered, half of the spacing, and also we have the circular grid, when the elements are arranged in the concentric circles. So let's start, let's do the rectangular grid here. So I have 8 rows. Let's put number of columns to 16. Element spacing here, half wavelengths. this one, let's see, 0.75. So here is the array grid. And now we can check out different plot types. So we can have pattern cuts here. We have the pattern at 0 degrees cut angle. We can keep this one here and check the pattern at 90 degrees as well. And next plot type is if we want to see it in 3D polar format. We have this beautiful curve here, and we can rotate it and look at it from other different angles. Also, we have the contour plot here, and here we can start scanning the angle. Let's say I want to scan the elevation to 30 degrees. I press 30 here. We move to 30 degrees. Here, let's say we want to go to 45 degrees. And here are our pattern to 45 degrees. Last plot type here is the polar surface. It's a more intuitive plot for polar format, especially when we can see that, okay, we are at 30 degrees in elevation and 45 degrees in azimuth. Last thing I'd like to mention here is that everything you notice here, the analysis was real-time. You can uncheck this one, and especially when you have large arrays, it's easier to first enter the numbers and then run the analysis. So let's do let's say 40 elements with 20 elements, and the spacing here may be equal to 1.5 lambda. Make it really huge array. We don't want to scan it, and then we can press analyze here. It's gonna take a couple of seconds, and here we can see our polar surface pattern. Since we have 1.5 wavelength spacing here, the grating lobes are showing up. Thank you for checking out this video. If you had a chance to go to the tool and actually try it, let us know your feedbacks here by pressing this feedback button if you see a bug or you want a feature to be added.